Hello again. Um, Welcome back to this video. It's Sunday, I believe. I'm recording that on Wednesday, so I'm not sure. And my name is Aga. Welcome. And I'll be watching the asteroid belt, the origins of the solar system from a geographics. And this is something that I'm really excited to see because I'm a big fan of the Expand show, and the belters and the whole story about the belt and things. Well, not whole story about the belt, but basically, I would like to learn something more. So let's just start. And yeah.
Today's video is brought to you by MyHeritage, an incredible genealogy platform to build your family tree and discover your origins. More about them. Roughly 4.6 billion years ago, out in the uncharted backwaters of the unfashionable ends of the western spiral arm of the galaxy, the solar system we call home was born. From a disk of dust and gas surrounding our newly ignited sun, the planets arose. Small, rocky worlds like Earth and Mars, great behemoths like Jupiter and Saturn. Alongside them formed moons and dwarf planets, and before you know it, our solar system was complete. A whole new cosmic neighborhood, born of primordial objects. Objects now forever absorbed into the larger worlds they became the building blocks of. Well, mostly absorbed. Today, there still remains a region beyond Mars made up of these planetary building blocks, a region filled with objects that have remained unchanged since the dawn of time. Known as the Asteroid Belt, it's one of the most spectacular structures in the heavens. Spread in a ring between the orbits of Mars and Jupiter, the belt is a veritable time capsule, home to millions of fragments documenting the origins of our solar system. Yet, there's more to the asteroid belt than mere history. A place of dwarf planets and shattered cores, of binary systems and water ice, it's also a region of tantalizing mystery. Go on NASA's website and visit their page on asteroids, and you'll see a discrete counter keeping track of all the asteroids ever discovered. At time of recording, that number stands at 1,113,527, a colossal figure that's nonetheless thought to be a mere fraction of the true total. Scientists believe there could be as many as 1.9 million large rocks in the asteroid belt alone, with millions upon millions more that have diameters of less than 1 kilometer. That would mean the region between Mars and Jupiter is crammed with objects still waiting to be discovered. If you want to try and visualize it, you might picture something like that scene in Star Wars when Han takes the Millennium Falcon on a daring drive through a dense place of clashing rocks and weird worm monster things. But here's the kicker. As you may already know, real asteroid fields are nothing like the cram-packed one in Star Wars. While 1.9 million large rocks may sound like an awful lot, the truth is there's really not a lot to the asteroid belt. Altogether, it's thought the total mass of the belt is less than 1,000th of that of the Earth, and a third of all that mass is locked up in a single object, the underrated dwarf planet series. That means the vast majority of the asteroid belt consists of empty space punctuated by occasional hunks of rock from 500 kilometers in diameter to less than 10 meters. Not that hunks of rock is the right way to think of them. Asteroids come in all sorts of different styles, with some as solid as a planet, and others mere rubble piles held together so loosely by gravity they will sink inside any of them will be trying to stand on. When the OSIRIS-REx probe recently took a sample from the near-Earth asteroid Bennu, for example, the gentle touch of its sample retriever was enough to blast a vast crater into the surface, so lightly was Bennu being held together. But this doesn't even begin to demonstrate the variety of asteroid types out there. Officially, NASA places these space rocks into 3 classes: C-types, S-types, and M-types. Of these, the C-type are the furthest away, dominating the outer belt in the direction of Jupiter. Made of clay and silicate and containing lots of carbon, they also show evidence of water. In fact, it's thought they may have originally brought H2O to Earth in primordial collisions. So, well, thank you for that. At the other extreme of the belt, closer to Mars, is where you tend to find the S-types. These are the stony ones of sci-fi lore, dry lumps of rock without water, pockmarked by craters and looking like they might house monsters or clangers. Finally, you get the M-class, partially melted metal types made of nickel iron that may have once, billions of years ago, swam with molten lava. Now, this is just one way of classifying asteroids, by composition. If you're looking for another way, you can also include position. While this video is going to focus on main belt asteroids, the ones that, as the name suggests, orbit in the belt itself, there are also near-Earth asteroids and Trojans. Technically, Trojans are just asteroids that share their orbital path with a planet, but are perfectly placed so they don't either crash into it or get hurled away by its gravity. Mars has 14 Trojans, Earth has 2. Even Uranus is haunted by a pair of these cosmic butt gremlins. Really, though, most people talking about Trojans are referring to Jupiter Trojans, a cluster of 10,000 or so asteroids chilling out, relaxing, and maximum cool alongside the king of planets. But we'll save those guys for our inevitable future Jupiter Trojans video. Today, we're going to be all about main belt asteroids and what a motley crew they are. Aside from the absolute biggest members like Vesta, most inhabitants of the belt aren't uniform, but instead misshapen, cratered things with eccentric orbits and high-speed rotations. So high-speed that on the surface of many, a day would last mere hours. That's actually slow compared to some near-Earth asteroids which spin around in well under a minute. But even in the asteroid belt, some have been found with rotations lasting just over 200 seconds. Fast spinners or not, many also come with a companion. In total, 150 asteroids in our solar system are known to have tiny moons orbiting them. Now, not all of them are in the main belt. Some are trans-Neptunian objects, and others are, again, near-Earth asteroids. Still, a significant minority of main belt asteroids have at least one moon. Some, like 45 Eugenia, even have 2. Yet, for all the fascinating things we do know about the asteroid belt, there's one pretty major thing we don't know. Where the heck it came from.
Have you ever wanted to explore your family's history but didn't know where to start? Well, today's sponsor, MyHeritage, is perfect. With more than 19 billion records at your fingertips, MyHeritage is the #1 family history service in Europe that allows you to search for old family records you thought would be lost to time. Look, I've already made some incredible discoveries about my own family, from relatives I never knew existed. I've gone all the way back to, I think it was the 1850s.
Wow,
where my
that's
family
nice.
first came from. I couldn't find, that was kind of where I lost the trail. I'm sure if I do a little more digging, I'll be able to like translate some German records or something, because that's where I got back to. And I was like, okay. But it's been a fascinating journey. Not only is the information easily accessible, MyHeritage also provides a platform for repairing, colorizing, enhancing, and even animating your old family photos. MyHeritage lets you be part of something bigger too. With 19 million users around the world actively building your family tree, you won't just be discovering your past, but you can also connect with other users who share your ancestry. One of the great features of MyHeritage is their AI time machine.
I'm pretty sure that's the one that my sister set up years and years ago, and I keep getting emails from it.
And you're ready to take a trip back in time. Pretty amazing. Here's some B-roll of me having done that play right now. So
He kind of looks like what's his name? Jack Strong? John?
Create your family tree today with
No,
MyHeritage.
not Strong.
It's easy and
Is it Strong?
intuitive, so you can get started right away. It's a 14-day free trial and experience all their amazing features. And if you do decide to continue,
Oh, now I'm gonna have that stuck in my head. I don't know what his name is. Strong. For surname it's Strong, but definitely. Let me just check that. Short history.
Today we call the planetesimals in the asteroid belt the leftover building blocks of our solar system. But we didn't always think
Mark Strong.
until relatively recently. The leading theory was that all of these chunks of space rock weren't the remains of planetary formation, but the remnants of a planet itself. A long, long time ago, the theory went a rocky planet sat between Mars and Jupiter, a fifth sibling in the inner solar system family. But then something went badly wrong, and our unknown sister was destroyed, either in a gigantic collision or by the extreme forces of Jupiter's gravity. By the time the cataclysm ended, all that was left was rubble,
Is it-
which slowly migrated into
Is it
the
just
world
me
of
that went into thinking maybe there was some kind of civilization on it and they just destroyed it, like literally into pieces? But I'm guessing after so many years and stuff, first of all, they probably would be too early in the solar system's age to actually be able to evolve civilization into something like that. Or, and the other thing is as well, is just basically there would be some kind of let's call it archaeological finds in the belt. Although I don't know if they're making a lot of. Okay, you know what? Let's just watch it.
the sun. As theories go, it was a nice idea. Who doesn't love hearing about some ancient world forged in ice and lost in fire? Unfortunately, it was also, to use the scientific term, weapons-grade bullcrap. Scientists who investigated meteorites here on Earth soon realized that they couldn't all have a common source. They were simply too different to have originated from a single planet. Hence why today we have two wildly different theories to explain how all these asteroids got there: depletion and accumulation. To start with the former, depletion theory works from the basis that these are the leftover building blocks of the inner solar system. But then it tries to tackle a follow-on question. If that's the case, why are there so few left? The answer is Jupiter. The idea goes that after the solar system finished forming, there were a whole lot of planetesimals left beyond Mars's orbit, enough to construct several new Earths. But because Jupiter migrated in the solar system's early years, all that material got badly disrupted by Planet 5's intense gravity. So badly disrupted that most of it was hurled out into the depths of space. The asteroid belt we see today, then, is the tiny fraction of material that survived this process. By some estimates, 99.9% of everything in Jupiter's path was expelled from our cosmic neighborhood. Unless, that is, the accumulation theory is true, in which case the exact opposite happens. Rather than look at the asteroid belt and go, looks pretty empty, I wonder where all the material went. Accumulation theory instead frowns at the space beyond Mars and goes, looks pretty busy. How did all that material get there? In this scenario, there's nothing inevitable about having all of your leftover planet-forming material so close to the inner solar system. The only reason it all wound up gathering there is that the movements of Neptune, Uranus, Saturn, and Jupiter gradually pulled these planetesimals from their natural homes and dumped them all together. As evidence, look no further than the two biggest bodies in the asteroid belt, Ceres and Vesta. The only dwarf planet in the inner solar system. Ceres is a complex world with mountains made of water ice, patches of salt left over from evaporation, and possible briny lakes hidden below its surface. In this way, it appears much more like something we might
Looks
find
nothing
in
like the
solar
one in
system
Expanse.
near the orbit of Neptune. Vesta, on the other hand, has a composition straight out of the inner solar system playbook. The fact that two such wildly different objects now orbit relatively close together suggests the asteroid belt's material was dragged in from all over the place. If this theory is true, then the asteroid belt is all that remains.
Now I'm kind of curious, how big is
A natural
Ceres
disaster
compared
would
to
have turned
Pluto?
the solar system into a vision of hell, one in which flaming rocks crashed into young planets and life would have had no chance to evolve. Thankfully, that violence didn't last forever. After a period of crashing around like an angry teen, stomping and throwing things around, Jupiter at last mellowed out, grew up and settled into a stable orbit. The solar system calmed down again, and eventually life was able to evolve on Earth. Many billions of years later, that life gave rise to bipedal apes who one day invent instruments for peering up at the stars. In the year 1801, one of those apes, which went by the name Giuseppe Piazzi, would spot a strange point of light that no one had ever noticed before. A point of light that today we call Ceres. It was the first object ever discovered in the asteroid belt. It certainly wouldn't be the last. Just a little over a year later, Pallas was spotted. In 1804, it was Juno. In 1807, Vesta. Originally, astronomers thought all of these discoveries were new planets, but by the mid-19th century, so many had been found that they began to apply a new term to them: asteroids. And it would soon turn out that they were as interesting as anything the planets had to offer. In all the vast space between Mercury and Saturn,
Okay, I'll have
the
to pause this
asteroid
because I
belt
want
is
to
uniquely
see this through.
different.
So we've got Jupiter, Saturn's Hilda's triangle, main asteroid belt, so that's this here. Then we have Earth's Trojans here, that's Earth here. There's Mercury, Venus, Mars. Okay, and NEAs, what's the NEAs? Near Earth asteroids. Okay, so like that as well. Okay.
No other region of
Greeks?
comparable
What's
size
Greeks?
contains so little mass. But the fact
Jupiter
it's nearly
Greeks.
empty doesn't mean it isn't fascinating. Many of the belt's members are nothing short of spectacular. Most spectacular of all, of course, is the dwarf planet Ceres. But since we gave Ceres its own full video just 9 short months ago, we're
Really?
going to have to regretfully pass over our favourite underdog this time around. In its place, we're going to instead turn our attention to the belt's next biggest member, Vesta. An absolute monster of an asteroid, Vesta boasts a diameter of 525 kilometers, or over 326 miles. Now, that's far less than Ceres' 946 kilometer diameter, but it's huge for anything not considered a dwarf planet. In fact, Vesta comes close to meeting the criteria for dwarf planet status. Comprising 9% of all the mass in the asteroid belt, it's so heavy that it's nearly molded itself into a sphere through its own gravity. Not only that, but it also looks like a planet on the inside. Instead of an unchanging interior, Vesta boasts a core, a mantle, and crust similar to Earth or Mars. That means it had geological activity early in its life, complete with a molten interior kept hot by the decay of radioactive elements. This might have led to some of the surface features that we see today, but probably not all of them. for the simple fact that they may have been caused by something way more impactful. Taking place in the distant past, that impact is thought to have been a gigantic collision, one that saw an object so heavy hit Vesta that it left behind the Rhea Silvia crater, a crater a staggering 500 kilometers wide. And we really didn't misspeak there. That one crater really is 95% as wide as Vesta itself, although it isn't just an indentation. That at the center of this vast depression is one of the tallest mountains in the solar system, rising between 20 and 25 kilometers into the air. If the upper estimate is correct, it'd be even taller than Mars's Olympus Mons.
I was just going to say, I thought Olympus Mons was the tallest, and that was definitely not 25 kilometers.
Likely caused by the same impact, Devalia Fossa is a chasm 5 kilometers deep and nearly 500 kilometers long, longer than the Grand Canyon. So long that it loops around Vesta's equator, a great gash in the asteroid's surface.
That's
and
interesting.
what a spectacular surface it is. Forming a million years after the solar system was born, Vesta is one of the oldest objects we know of, and one with the widest range of brightness, going from brilliant luminance in some places to the blackest midnight in others. Then there's its impact on astronomy. Along with its near-twin Pallas, Vesta was one of the first asteroids ever discovered. Spotted in 1802, two Pallas are one of those things that's always playing second fiddle. Second asteroid belt object after Ceres to be discovered, second largest asteroid after Vesta, although that's a very close run thing. With a diameter of 511 kilometers, Pallas is only a hair smaller than its sibling with a similar mass. Still, it's only thanks to Pallas that Vesta ever got noticed. After German astronomer Heinrich Wilhelm Olbers spotted Pallas, he became convinced that the asteroid belt must be made up of remnants of a destroyed planet. It was while hunting for these remnants that he found Vesta, seeming to confirm his theory. Alas, though, the discovery of Vesta would knock Pallas out of the limelight for good. When NASA launched their historic Dawn mission in 2007, it was to explore the two biggest objects in the belt, Ceres and Vesta. From July 2011 to September 2012, the spacecraft circled Vesta, revealing this asteroid in detail Heinrich Wilhelm Olbers could only have dreamt about. Poor Pallas, meanwhile, has yet to receive a mission of its own. But that's not for lack of missions to the asteroid belt in general. It's time to meet one of the most intriguing residents of all, one that will be the target of an upcoming NASA mission, Psyche. Of the asteroid belt's best-known residents,
It's not the actual illustrations, that's not a picture, but still.
A full half century
Did you look at that?
Did
you look at it?
Objects like Vesta or even Hygeia, with a diameter of only 226 kilometers. Still, it's not size that makes Psyche so interesting, but what it's made of and what that might mean.
Metal?
Extremely rich in iron and nickel, Psyche is thought to be up to 95% metal.
Look at those craters.
Those two elements. And that's a tantalizing thought, because Earth's core has a similar composition, which has led some researchers to consider the most remarkable possibility of all. What if Psyche isn't just a mere asteroid, but the exposed core of a protoplanet that never finished forming, the heart of a long-dead world, wrenched out and cast adrift in
well,
space
it's possible,
without
I guess,
once
isn't
a
it?
chance to beat. Now, we
Well, I'm
should
not a
note
scientist,
that this theory
but-
isn't universally accepted. It could
Oh,
be
that's right.
there's something else going on with 16 Psyche that we don't yet fully understand. But the theory is accepted enough that NASA has planned a whole mission to investigate. Launching in October 2023, the Psyche probe will spend nearly 6 years traveling to this strange metal world, arriving in August 2029. There it will enter orbit around 16 Psyche for 21 months,
2029.
mapping its surface in detail, studying its composition, and trying to figure out if it really is the core of a failed small planet. The hope is that this will give us an insight into the core at the heart of our world, at the vital, hidden thing churning in the depths of the Earth.
I have
So
to apologize for
integral
some
to life.
background snoring.
Yes,
Abby is sleeping
Annoyingly,
currently in
we
the
could have
bed.
got the answer to this question a
She's
lot
not.
sooner had it not been for a software glitch. Originally, the Psyche craft was scheduled for a 2022 launch, which would have allowed it to make the journey in only 4 years instead of 6. But because it had to be pushed back, the revised launch window has now had all sorts of unfortunate knock-on effects, including pushing the Venus probe Veritas back from a 2027 liftoff until 2031. So, apologies to anyone who watched our Venus video and got all stoked at the idea of Veritas taking off in the next half-decade. You've now got an additional 4 years to wait. However, the visit to 16 Psyche will hopefully be worth it. Because there's some rock mixed in with Psyche's metal surface, it's thought this could be part of the ancient mantle that once wrapped this frozen core, yet another window into the process of planet formation. That would be an amazing thing to uncover, yet it's only one of the multitudes of asteroids that would be worth a dedicated probe. There's also 253 Mathilde, a carbon-rich rock 52 kilometers across that's one of the darkest objects in the solar system,
Mathilde.
reflecting a mere 4%
Wonder
of the
whose
white
child
dwarf.
is that?
Not only that, but its surface is thought
I
to be
mean,
profoundly ancient,
actually, whose child was
unchanged
that?
in 4.5
Or maybe
billion
a mother.
years, and therefore
Who
holding
knows?
a record of conditions at the dawn of time. Or how about a return visit to 243 Ida, passed by the Galileo spacecraft in 1993? Its moon Dactyl was only discovered in the photos the probe took, meaning its origin is a source of mystery. Or what about the ice-covered 24 Themis, which may once have been part of a series-like protoplanets? Clearly, there are many compelling reasons to launch more missions to the asteroid belt to explore in depth many of these building blocks of our solar system. Sadly, though, that's not how the people holding the purse strings see it. Aside from the upcoming mission to Psyche, our chances to visit the main belt in the coming decades are depressingly low.
Aww.
When it comes to great asteroid belt missions, the gold standard will likely always remain Dawn. Launched in 2007 as part of NASA's cheaper class of Discovery missions, Dawn was the probe that visited both Vesta and Ceres, spending 14 months orbiting the largest asteroid before swinging off to investigate the only unexplored world in the inner solar system. Arriving in 2015, it became the first probe to ever visit a dwarf planet. Pipping New Horizons visited Pluto by 4 short months. The probe then orbited Ceres till 2018, sending back detailed data that upended everything we thought we know about this part of space. Combined with the things we learned from its visit to Vesta, it transformed our understanding of the early solar system. Not bad going for a mid-cost mission. In short, Dawn showed that it's possible to do impressive science in the main belt at an affordable price, and more recent probes have borne that idea out. Although aimed at near-Earth asteroids, NASA's ongoing OSIRIS-REx mission and JAXA's completed Hayabusa 2 have both carried out successful sample collections. Last September, the DART probe likewise gave us a close-up of a near-Earth object, in this case by smashing right into it or with the camera rolling. What we're trying to say is that asteroid missions are clearly something a lot of space agencies currently have time for. As we speak, NASA's Lucy probe
I'm
is
sorry,
en route
this
to
one
the
looks
Jupiter
funny.
Trojans to study multiple members of
Because
this
it's smiling.
asteroid family in detail. And as we've already said, there's the upcoming Psyche probe to one of the main belt's weirdest objects. Sadly, though, that's as far as it goes. While Lucy will have a flyby encounter of main belt asteroid 52246 Donald Johanson on the way to Jupiter, that's really just a bonus, a fleeting visit undertaken out of convenience. The Psyche probe remains the only scheduled, dedicated mission to the main asteroid belt. And that's truly unfortunate, because this region of space may be one of the most important that we can study, the place where the raw fragments of the planets can be found, in the state they existed in 4.6 billion years ago. But now for the twist, for the surprise note of hope to end our tale on. The news that while no missions are scheduled, that doesn't mean there aren't any in the works. Many thousands of kilometers away, China is currently working on the next part of its hyper-ambitious space program, the mission known as Tianwen-2. Back in the spring of 2021, Tianwen-1 landed a rover on Mars, making China the first country to successfully do so after the United States. Now, for their next trick, the current plan is for China's scientists to send Tianwen-2 on an asteroid sample return mission. The first leg won't be so different from OSIRIS-REx or Hayabusa 2, a visit to a near-Earth asteroid followed by a sample
Return,
collection.
huh?
The next leg will then see that craft swing around Earth for a gravity assist before zooming off to the asteroid belt. Finally, in 2034, it should enter orbit around the active main belt asteroid 311P Pan-STARRS. And this could just be the beginning. In the latest decadal study, NASA were told to prioritize for their New Frontiers program a sample return mission to Ceres to land and search for signs of water and organic compounds. If selected, it should launch in 2030 to arrive at Ceres in 2037, just 3 years after Tianwen-2 likewise enters the main belt. That means that far from a barren asteroid science wasteland, the 2030s could be a golden age of main belt exploration. A decade in which 3 probes, including Psyche, explore 3 separate objects in this most underrated regions. And what they find there may well change everything. As we love to do with these space videos, we're therefore ending today on a note of hope, on a vision of the future in which the main belt will soon, if we're lucky, become the site of some serious exploration, of missions that will write the next chapters in the great book that's titled Human Space Exploration. And we, for one, can't wait to read.
It's true. And I would love to see that. So, what do you think about that? Most important question, have you seen Expanse? Because I do recommend that to everyone. Everyone, no matter if you like science fiction or you don't like science fiction. Not everyone takes my recommendation seriously, so you know. Anyway, this one was very interesting. I learned a few new things. Like, few new things. I'm not going to name them now. But yeah, that was cool. And now I kind of want to watch The Expanse again for the like 5th time, I think. Okay. Thank you very much for watching, and I'll see you tomorrow. Bye.